Hi, so good morning, and uh, so today the problem is number of ways to arrive at destinations. Uh, the problem is related to the I think graph. So the problem says that you are given a weighted graph with b vertex. What it says number from 0 to b minus 1, which means and e edges represents as a 2D array. Okay, edges, and where as I is equal to ui bi and time I. Okay, means that there is an undirected edge between nodes ui and bi. The task that that takes time minutes to reach. How your task is to return in how many ways you can travel from node 0 to node b minus 1 in the shortest amount of time. Okay, so the problem is says that like you have to reach at the destinations, and from the source to destinations how much ways you reach on the destinations. Okay, and amount of time, shortest amount of, and minimum time taken, and then you will reach in the destinations. So that is the problem. So now understand the problem. Now what is the problem says, which means a graph undirected and weighted. Correct, there is no directions from where to where we have to reach. So that is the undirected graph and weighted. We need shortest time from node 0 to b minus 1. Shortest time from 0 to b minus 1, right? And number of ways to reach the shortest time, and number of ways we have to count the number of ways to reach shortest time, right? From the source to destinations. So what we have to think, so basically if we have to find the shortest distance, so what we think, always think Dijkstra algorithm. What? Dijkstra algorithm, right? So we will use here Dijkstra's algorithm. But what a twist! The twist is normal Dijkstra's find shortest distance. Normal Dijkstra's only find the shortest distance. Here we also track ways of I, number of ways to reach node I with shortest distance. Here uh, we also track number of ways to reach node I with shortest distance, right? That is the main thing. Now what is the logic? So first thing is create a graph which is vector pair. Why? Because that is the pair. And then initialize distance and the ways, right? And use the mean heap for the priority queue. From if you have to initialize, then which one is go at the first time. So for that then we can use the mean heap. Now Dijkstra traversal for each neighbor found shortest path. For each neighbor found the shortest path, and then update distance and copy ways. All the ways we had waste, we just copies this all. Then found the another shortest path. Then we found the another shortest path, right? And then we just have to add the shortest path. Why we can add? There is the concept. The concept is like if dist of b is equal to dist of u plus w, then ways of v plus ways of u, right? And the meaning is if another path gives same sort of distance, add ways, right? If another path gives same sort of distance, if another path give the same sort of distance, then that is also add, right, in our data. So if I will uh, if I will explain, right, in a single way how we think and how to use. So the first thing is, first find the sort of distance. First find the sort test distance, and then count how many ways we reach each node with that distance, right? And if same distance comes again, then add ways, right? And the final answer is equal to ways of p minus 1, right? So this is the main concept, right? And simple summary. Now I just write the code and then I explain how to pass all the test cases. At the end we just have to focus on the pass all test cases, and we just know how to approach this code, right? So start from the create adjacent list, right? uh, Create adjacent list, right? So vector uh, where int adjacent adjacent, right? Adjacent, right? uh, Adjacent of b, correct? Now for auto address of e to edges, right? And then int u is equal to e dot 0 to b dot b is equal to e to 1, and weight is equal to e of 2, right? That is b vertices weight. What is the weight? So that will show in there. Now adjacent of u dot push, right? Push back of v to wt, and adjacent of v dot push back of u to wt, right? Now mean heap. Now mean heap, right? So priority queue of pair of long long int, right? And here we just have to find the two things: vector pair long right int, and then greater pair long int pq, right? So that is the priority queue. Now step 3 is distance and arrays, है ना? यहाँ पे क्या हो जाएगा? Distance and ways. Now vector long long dist of v to long max, right? And then vector int ways of v to 0, correct? Now dist of 0 is equal to 0 and dist of 0 is equal to 1, right? pq dot push of 0 to 0. Now Dijkstra algorithm. Dijkstra. Now while there is only what test case is pq is empty till auto top is equal to pq dot top and pq dot pop long d is equal to top dot first and int node is equal to top dot second for auto it of adjacent of node, right? So what there is, if auto it adjacent of node, right? At that situation what you can do, so at that situations I just go and she for auto then there is a int of adjacent node is equal to it dot first and int wt is equal to it dot second. Found shortest path, then found short path, right? So if d plus wt weight greater than or equal to distance of adjacent node, then distance of adjacent node is equal to d plus weight, correct? And then pq dot push of distance of adjacent node to adjacent node, right? And then weight of adjacent node is equal to weight of node, right? And at the end only for the found another shortest path, right? So else if d plus wt is equal to dist of adjacent node, then weight of adjacent node plus weight of node, right? And here is return weight of v minus 1, right? Here now compile and run. Yeah, where is the error? The error is not start from here. Okay, so I see the problem. So yeah, the problem is now find and just write the very clean code. Now you just see there is no any problem. Now found, I will explain the steps, right? First is create adjacent list and then use the min heap for the distance, node and distance, and then distance and weights array, like how much distance and how much weights there. Now use the Dijkstra algorithm here, and after that found the shortest path. If I can found the shortest path, then I just go on the another shortest path. If these both are fine, then correct, and then compile. Yeah, it will run. And if I will submit, then pass. Yeah, it will pass all the tests. So you see, yeah. So now, what is the time complexity of this, right? That is a very important questions. What is the time complexity of these questions? So the time complexity is order of E log B. Why E? E is edge or B is vertices, right? So that is the time complexity, and the space is order of B plus E, right? So that is the time, and that is the space. So thank you for staying till the end, and please subscribe and like my channel. Thank you so much.